Chapter 8, factoring by grouping, and then we'll do type 1. So there will be two different methods of doing factoring in this slide. The first one will be grouping, and the type 1, we call that because the coefficient of the quadratic term is 1 only. Okay, so let's get started. All right, so when we factor by grouping, that's mainly used when you have 4 terms. You'll group the first 2 terms, generally speaking, with parentheses, and then you'll group the last 2 terms together. Then you're going to factor out the GCF from the first group. Then you're going to factor out the GCF of the second group. So it will be 2 different things. And then you're going to write the repeated factor once, and then put your leftovers together as your second factor. For example, when we have 4x squared plus 4x plus 5x plus 12, I would put a parenthesis around the first 2 terms. Whoops. Okay, whoa, let's fix that. That's not good. Okay. These 2 terms, and then these 2 terms. There, it looks better. Now notice on this second one, whatever sign is in front of that third term right here, it needs to be with this parenthesis set, okay? So make sure you do that. All right, so what is in common between 4x squared and 12x? Well, we know that 4 goes into both of those, and we also have an x in common between both of those. So you take your GCF out, and then you divide. What is 4x squared divided by 4x? Well, 4 divided by 4 is 1. If you need to, put a 1. And then x squared, take away 1, means I have 1 left over. Then you do positive 12 divided by 4, which is a positive 3. And then x and x, if you take them both away, then that means that you have no more x's, and that's done. Then you do the second group. What's in common between 5x and 15? Both of them have 5 in common. That would be a positive 5, so I'm going to put a plus 5. And then I'm going to GCF that out of this binomial. 5x divided by 5 leaves me with just 1x. And then 15 divided by 5 is going to leave me with 3. Now, you'll know you did this right if this and this are exactly the same. Okay, can I have sign differences? It has to be exactly the same. You don't need the 1 there if you don't want to put that, that's fine, but you do have to have x plus 3, and they both have to be that. If they're not, then you need to go back and redo it. What you'll do then is, because they are the same, you'll write one of those, and then you're going to put your leftovers together. So that's going to be 4x plus 5. All right, now it does not matter if you put the 4x plus 5 first and then the x plus 3, but you need to make sure that they are grouped together, okay? That you just can't just put it together and then start adding things. These are separate quantities, this and this, so it has to be separated, right? So the goal of grouping is to end up with that common factor right here, and if you don't, like I said, you need to go back and fix it. You can always double check to make sure it's working. If you get confused, 5 times 1x gives you 5x, 5 times 3, 15. So you can go back and check that. What this will make, if you multiply this together, this will make a polynomial, and then you will be able to have it from going from one direction, which we did last week, where we were making the polynomial. Now we're taking it apart. Okay? So let's try another example. Oops, this is all type 1. Well, let's do an example of grouping, another example of grouping. Let me write it up here. Say we have 2x plus 4, and I'm going ahead and put the parentheses around the groups. 3x plus, let's see, 6. Okay? I went ahead and grouped them so that we can work on it. What would be in common between 2x plus 4? 2 can come out. So you would have x plus 2 when you divided it out. What would come out between 3x plus 6? A positive 3 would come out, and you would have x plus 2. Generally speaking, this should have an x. There you go. That would make it look a little bit better. Yeah. All right, so when you do that, you put your leftovers together. That would be 2x plus 3, and then x plus 2. Okay, that's grouping. All right, and the next type is type 1. And the nice thing about type 1, they have these rules, and if you learn the rules of these signs, then you will have no problem with any kind of factoring that you'll ever have. You must always remember to GCF first. You have to find the greatest common factor to take that out. If you don't do that, you end up having to factor several times. So take that out, and a lot of times when you do that, you'll see the special patterns that we'll be talking about, and then you'll know exactly how the pattern should be breaking down. The coefficient of the quadratic term, there's a new word, quadratic. That is the x squared term, okay? So that is the term that's quadratic. It will make a parabola like this or like this that we'll talk about when you graph it. But the quadratic term, which is the term of the highest degree that should be in the front of your equation, must be 1. It cannot be any more than 1, or we have to do a different way of factoring. All right, so we're going to find the factors of C that will add and subtract to give you B. So you have AX, your standard form, plus BY equals, oops, not equals, plus C. Okay? All right, so A, B, and C. So what they're saying is factors of C that add or subtract to give you the B. Okay, and you'll understand more when we start doing them. And then you're going to form two binomials from those factors. So let's talk about the rules of the signs. When you have a problem, and they're going to be in descending order, something like this. Okay, where this is the quadratic term, it's the highest degree of 2, and then this is a degree of 1, and this has no degree. That is in your standard form. When you're doing this, if there is a positive constant term in the back of this trinomial, if this is a plus back here, then the signs will be the same when you break it apart. They're either going to be positive, positive, or negative, negative. Because when you multiply, a positive times a positive is a positive, and a negative times a negative is a positive. So if it's a positive in the back end, it will be the same sign, either plus, plus, or minus, minus. Then you look in front of the linear term, this term right here in the middle, and it says it's plus. If it's a plus, then the signs have to be plus, plus. Okay? If there was a minus right here and a plus in the back, that would be a minus, minus. All right? So you look in the back to see if they're the same signs, and then you look in the front to see which one it is. Okay? Now, if there was a negative, let's change this. If there was a negative, say, yeah, okay, yeah. There was a negative in the back, that means different signs, because the only way you can get a negative by multiplying is multiplying by a positive and a negative. So that would mean it would be different signs. And then you look right here, and once you find the factors that make this, they're going to subtract to be this. The biggest of the two numbers that you find gets the sign of the one right here. And that makes no sense at all, but let's just go ahead and start working on one, and we'll explain the signs as we go. Okay, so example 1 says x squared plus 14x plus 40. Notice that we have a plus in the back end, so that means that the signs are going to be the same. So what you do is you start and you make couple sets of parentheses. Make it big enough where you can put two numbers in there, okay? These are going to be our factors. All right, so we know that it says positive, so that means the same sign. You look in the front, and they're both going to be positive. So you go ahead and write that in, plus, plus. All right, now, how do you split up, if you were going to share x squared, and this is one person, and this is another person, how would you split up x squared? Well, you would take and just say x and x, okay? Because x times x makes x squared. So that's split up. Now, if you had x to the fourth, you would have x squared and x squared. So you just split the x's up. Then you say factors of 40, things that multiply to give you 40, but add to be 14. So if you need to make a little table, you would make a little table like this, and you say factors of 40 that add to be 14. And then you decide what things multiply to give you 40. Well, that's 1 and 40, 2 and 20, 4 and 10, 5 and 8, okay? Those are some of the things that multiply to give you 40. But I need a set of these that's going to add to be 14. So 1 and 41 make 41, 1 and 40 make 41, 2 and 20 make 22, 4 and 10 make 14. So it's going to be these two. Okay? So then you just split them up. Use 4 and 10. It doesn't matter where you put them because all your signs are the same. Okay, you could put x plus 4 in the front of x plus 10, that's fine. But this is now factored. If you multiply this through and did our little box method, you have x and 10 and x and 4, made your box. You get x squared, 10x, 4x, and 40. And you put your like terms together, guess what? You get this equation. Okay? So we're taking the equation, it's not really an equation, a polynomial, and we are going backwards and making factors. These things in parentheses are called factors. All right, so these are the things that multiply to give you that. All right, and if you want to, like I said, you can check by distributing or you can check and do the box method, either way. All right, let's see. All right, so another example, x squared minus 6x plus 9. This is our quadratic term. It has a coefficient of 1, so we know we can use type 1 rules to factor this. We look in the back, and it's a positive, so that means it's going to have the same signs. Go ahead and do your bubble, parentheses, whatever you want to call them. Same sign, but we look right here, and they're both going to be negative. We split up our x's. This is x squared, so each one gets 1. And then you say, factors of 9, what multiplies to give you 9, but adds to be 6. Make your little table. Multiplies to give you 9, but adds to be 6. 1 and 9, and 3 and 3. Which one adds to be 6? Of course, 3 and 3. So I'll put a 3 here and a 3 here. Now, sometimes you'll see that written as x minus 3 quantity squared because it's the same exact thing. Either one is acceptable. And if you multiplied this out and did your box or distributed, you would come up with this polynomial. Okay? Let's try this one. I'm going to erase this right here so I have some room. All right. This one says x squared minus 3x minus 10. This is our quadratic term. This is our linear. This is our constant. All right. We look back here and it is a minus sign. That means opposite sign. So we go ahead and make our parentheses. One's got to be positive. One's got to be negative. Does it matter which one you start with? No. But it will matter when you put your numbers in. Split up your x squared. X and x. Then we're going to make our little table and we're going to say factors of 10 or things that multiply to give you 10, That's subtract this time, because there's a subtraction there. Subtract to be 10. Okay, excuse me, subtract to be 3. What multiplies to give you 10, but subtracts to give you 3. All right, so 1 and 10 multiply to give you 10, 2 and 5. Which one subtracts to give you 3? 2 and 5. Okay, so now the trick with this is we have to have a -3 out of these two numbers. Okay, so which number of these two is the biggest number? Well, 5 is the biggest number. Well, 5 will get whatever sign is right here. So it's got to be a 5 on the minus and a 2 on the positive. When you box that or distribute it, you will get this answer. You have to be very, very careful when you have one positive, one minus as to where your numbers go. Okay? So again, you could put x minus 5, just like I did here, in front of the x plus 2. Does not matter. All right, so let's do another one. It says x squared plus 7x minus 18. There's a minus in the back, so that tells us automatically different signs. Split up my x's. You're almost done. You haven't really gotten anything done yet. Then it says, make your little table, factors or things that multiply to give you 18 but subtract to be 7. So I'll put 18 sub 7. All right, what multiplies to give you 18? 1 and 18, 2 and 9, 6 and 3. Which ones subtract to give you 7? That doesn't, but this does. All right, then you look. The biggest of these two gets the sign that's in the front. So that means it has to be a plus 9 minus 2. Plus 9 minus 2. Okay? And the more you practice these, the better you'll get. It does take a little time to do this and get into it, but once you start seeing the pattern, you'll go really, really fast. Okay? Let's see if I have any more. Nope. All right, so we will practice this in class. Be prepared for lots of examples, and we've got to do a lot of practice on this to get really good. So be ready for that, and I will see you in class.